So in this video, I'm going to create a game using Pygame, and the main point of this video is to teach you about how to import files, how to create your own files for import, and some good strategies for using import to organize your code. So I'll run my program and show you what I've got currently. So currently what I've got is that I draw a bunch of squares on the screen, a bunch of rectangles really. I have a yellow rectangle that represents the player. Red rectangles are going to be obstacles that I need to avoid, and the green rectangles are going to be collectibles. Basically, I want to collect all 3 green rectangles, and then I win. That's the whole thing of the game. I think I'm going to add one enemy that chases you later on, but that's all there is to it. So let's get started. Now, I have all my code, a lot of my code written here already. So I have a function to handle events. I get the Pygame events. I've got a bunch of comments written. I go down here. I initialize a bunch of variables, including a bunch of colors that I may want to use. I create a rectangle for the player. I create the deadly rectangles, the red ones that I want to avoid. I create my 3 goal rectangles that I want to collect. And then, of course, I have my code to draw things and react to keyboard input. Now, I'm actually going to start with some organization. So what I'm going to do is I'm going to create a new file. You either go up to File and then select New File, or I'm just going to press Control-N. And so now I have this new file here. I'm going to empty it out. And I'm going to store all of my constant variable values in this one location. So I'm going to take all my colors. I'm going to cut those out. I'm going to paste them over here. I'll save this file. Let's see. Now, it looks like it didn't save to where I wanted it to, so I'm going to go to my desktop. Oh, I'm calling this Scwary Squares is the name of my program because it's going to be Scwary. And I'm going to call it constants is the name of the file, constants.py. So I save that. I'm going to go back to my main file. And you know what? Screen width and screen height, those aren't going to change either. I'm going to copy those over and put those into constants. All right, so let's save this and make sure this works. Okay, so back in my main file, I'm going to go up to import right here. And I've got this other file named constants. So I just make a comma, and then I type in that file that I'm going to import, constants. Actually, you know what? No, we're going to do this a different way. We will do that later. But there's a handy thing that you can do, especially with your constant values, is you can say from, and then the file name, constants, import, and then an asterisk. And what this says is import everything from that file as if I just copied all the code right here, as if the code was copied. Yeah. So I'm just going to write that right here. And now it's as if I had all those constants just pasted right into this line of code, as if I had this other file copied and pasted right there. And I should be able to run this with no problem. And there we go. I got the same screen as before. And this is nice because my code in my main file is a lot shorter. Now I've still got some variables. I've got the clock, I've got the surface, but those are Pygame things, so I'm going to leave them in here for now. Here's some other things that I'd like to clean up though. I've got how many deadly rectangles to create, 100, and that's just this number here. And it's not clear from my comments or anything else how I chose this number. So here's what we're going to do. Instead of 100, I'm going to say num deadly, the number of deadly rectangles, and I'll go over to constants and I'll say num deadly equals 100. And that just feels easier to read for me. How many deadly rectangles? Well, num deadly is the number. How many goal rectangles? Well, we'll call it num goal. And then we'll go over into constants and we'll say num goal equals 3. And then lastly, and I really like this one, you see all these 5s hanging around? It's really not obvious what all these 5s are about. But since I do know what they're about, since I wrote this code, I'm going to create a variable called rect size. It's going to be the size of my rectangles. And I actually don't like 5. It's kind of hard to see on the screen. Let's try 20. Let's see if that's too big. So I go back over here, and I'm going to replace all these 5s with rect size, which also helps remind me that when I'm creating one of these rectangles on a line of code like this, that the last 2 arguments are the width and height, the size of my rectangles right here. All right, so let's go ahead and run it and make sure this works. All right, not only does it work, but my rectangles are a lot bigger. Now I actually forgot to do it for the player, so I'll make the player slightly larger. I like this size. This is easy for me to see, so this is what I'm gonna use as the size. But suppose that I didn't like the size of my rectangles. Suppose that I wanted to make them smaller. Well, it's real easy. In fact, maybe this will be even better. I just changed this one number right here, and now I've changed every single one of my rectangles on the screen. These are slightly smaller. You know what? This will be a good size to use, right? So if you ever make a decision later on that you don't like the value that you had, now it's really easy to change that. And we've got all these numbers in the same place, right? So if you want to modify your game, more deadly rectangles, maybe you want the level to be more difficult, you can change these numbers all in one place. So this is a really good way to organize your code, is to create this constants file. So another good way to organize your code is to put lots of functions into their own little file. So I'm going to start on that, and we're going to add to it later on. So I'm going to just do Control-N, again, to get a new file right here. I'm going to put my functions here. And I've already got one function. It's the handle events function to handle all the mouse and keyboard events. And I can cut and paste this over to my new functions file right here. Now, one thing that I will have to be aware of is, since this function uses Pygame a whole bunch, I will now need to import Pygame at the top of this file. So that's no problem. That's pretty easy. Also, my player is modified. This is actually going to be the player rectangle. I copied this from some Flappy Bird code. The player gets modified, so I should probably pass the player in to this function. All right, so I'm going to pass the player into this function. I've changed this function a little bit. So now I need to look at where handle events gets called. So I go down into my code. Here's handle events. And I'm going to pass the player to this function. I should save this file. Great, I need to do that. I'm going to call it functions. I'm not done yet because I still need to import this file. Okay, so back up here, we've got our imports. I am just going to import it as functions, right? Just like I did random, just like I did Pygame. Now that I've imported it as functions, I can't just call the function as handle events. I have to say functions.handle events, so that it's clear that which handle events function am I calling? Well, the one that's in the file named functions. Now, I could have used from functions import star like I did with constants, and then I wouldn't have to put the functions dot before handle events. But for this purpose, I like doing it this way to demonstrate that this is a good way to do it. And also, it can be nice to organize your code this way because now I know where that handle events is. If I look, oh, handle events is in the functions file. I can find it easily. Let's run this and make sure I haven't broken anything. All right, it still works. And I can even press up, and that's the only movement that I did for my player. And I can move the player up, so that's kind of nice right there. The next thing I want to do is I want to create an object for my player, because the player is going to get a little more complicated in how it moves, and it needs to have a collision function and some other things. So I'm going to create a new file, as usual. And this might be a good review for folks who need a reminder of how to create objects. So I start with the word class. Sorry, I'm actually going to create a class. Class is a blueprint for an object. So this tells me how to create a player. And I'm just going to call my class player. Use a capital P to start the name of your class, and then a colon. And then the first function we should always write is init. There are 2 underscores before init, and there are 2 underscores afterwards. Why? I do not know. It doesn't seem like the best way to do it. And then I need to say self. Every single function, which is actually called methods, every single method that a class has needs to start with the argument self in parentheses. That's how objects refer to themselves. Okay. My object is going to need an x coordinate. It's going to need a y coordinate, and I think it's going to need a size as well, And let's just start with that for now. So I'm going to pass these values in. So I need to put little placeholders in the init function so that I can pass these values to the self values, right? X and self.x are not the same thing. Self.x is the x that belongs to the player, and x is the value that's passed in to the init right here. So before I go much further, let's save this file. I'm just going to call it player. And then let's go back to our main file here and look at where we create player. Okay, so player currently is simply a rectangle. I would like to change it. I'm just going to comment this out. I would like to change it so that it is no longer a player. It is this object that I've created. Now, before I do that, I need to import the file. Okay. Now, I've actually named my file player. If we go over here, I named this file player. I named the class capital P player. That's okay as long as the capitalization is different. I'm going to go up here. I'm going to import player. And then I'm going to have to choose a different name. I'm just going to call it P. It's not the best variable name, but sometimes we get low on names like this. I could have named the file character or player rectangle or something like that, but we're going to move forward with what we have. So P equals, and then player is the file name dot capital P player, and you can see the autocomplete right there is suggesting it to me, so I'll just hit enter and use it. This is the class that's going to create this object for me. And then I need to pass into the parentheses the arguments that init expects. It expects an x, a y, and a size. Well, previously I was using rect size for the size, and I was using 100 and 100 for the x and y. So I will just put those in, and we should have our same player as before. Now, actually, before I go onward at all and make this too much more complicated, I want to make sure this works. And I already know that it's not going to work because I had a player that now is just called P. Okay, so that's an easy fix. I'm just going to call it P when I handle events. But that's not the only place I did it. I also drew the player right here. Now I would like to move the drawing function into player.py. So let's go ahead and do that. So I will create a drawing function right here. I will call it draw. I need to start with self. I'm going to pass the screen on which to draw this player object to the player. I'm going to create the rectangle for the player just inside the draw function. I will explain why I'm doing this momentarily. I don't want to use 100 and 100. I want to use self.x and self.y. So that when I change my self.x and self.y, I'll actually change the position of the rectangle. I could use rect size, but I'm going to use self.size. Otherwise, why did I pass it in? All right. So I've created this rectangle, and now I need to draw it. Well, if we go back to our main file, this line of code that's already highlighted, that's where I'm drawing the player. So I'm going to cut that out, move it over here. So one of the things that I hope you're seeing is that it's okay to write some code and then decide that you want to reorganize it and move it to a different location, which is pretty much what I'm doing here. So I'm going to draw it on the screen because that's what I called the variable name. Yellow. Player actually doesn't know about yellow yet. How can we tell player what yellow is? Well, we could pass in the color right here as an argument, and I think that's actually the best way to do it. So let's pass in the color. And now instead of yellow, we're going to use self.color. Great. So now we're going to call this drawing function in main. So it's going to be p dot, and again, autocomplete is your friend. There's draw right there. Parentheses. I need to pass in the surface or the screen. I should have really been more consistent about my variable names because I called it surface here, but in player I called it screen. But I'm just going to let that go for now. And that's all I need. However, I changed the init function of my player so that now I need to pass in the color, which is yellow. Let's call this and make sure it works, or run it and make sure it works. It doesn't. I made a mistake somewhere. Pygame's not defined. I forgot to import Pygame in here. Okay, that's an easy fix. Great. One other thing you're noticing is you can import Pygame in multiple different files. Nothing wrong with doing that. All right, our game runs, looks good. The next thing that I want to do is I want to make the player move around. I'm going to speed through this portion of the video, but I'm going to write some code right here so that the player can move a little bit more smoothly. One of the things I'm going to do that's very helpful is I'm going to create a speed variable for the player. So actually, I'm going to call it default speed because I might make it so that my player can change speed at different points in time. I don't know what the best value is, but I'm just going to start it at a number that I've arbitrarily chosen, and we're going to see how that number works. I'm also going to import constants, and I'm just going to import speed. From constants, import default speed. I can import only the things that I want, and this is how you do it. You just say from whatever the file name is, and then import and whatever variable you want. And then in this function, when I move it, I can move with this default speed right here. So I'm testing my code right here, and I have my player rectangle moving around the screen. I would like it to move a little bit slower, actually. So thankfully I have this constants file, and I can just easily change this default speed. I'm going to cut it in half to 2.5, and I can run it again and test it very easily. All of my constants to change how this code runs are in one place. Very nice and easy to change. Next thing I'm going to do is I'm going to write some collision code for my player. Again, I'm going to speed through this. I think it's handy to organize all our collision code into a function. So I opened up my functions.py file, and I'm going to create another function here that is def check collisions. And I'm going to pass it the player, and I'm going to pass it the deadly rectangles to avoid, and I'm also going to pass it the goal rectangles that it wants to pick up. And I'm just going to check all of my collisions in one place so that I'm not cluttering my main file. And now I'm going to speed through the creation of this code right here. So it's worth talking about some of what I just did there. So I have a loop that goes through and checks to see if the player collides with any of the deadly rectangles, and if the player does, I print game over, and then I exit the game. Then I have a second loop that checks if the player collides with any of the goal rectangles. If the player does, then what I'm going to do is I'm going to increase the player's points. I'm going to check to see if the player's points is greater than or equal to num goal. This is the number of total goal rectangles that I've created. And I passed this in by importing it from constants. I just put a comma after default speed because I realized I also need to know the number of goal rectangles. And now I can check and see if I've collected all of them. And this is really nice because if I want to change the number of rectangles, I just still go to my constants file and I just change this number right here. And my victory condition, the number of rectangles that I need to collect, will change automatically, which is a really handy thing to have. Now, one thing I just realized is that I actually want to delete the goal rectangles out of the game once I've collected them. So I'm going to need to run through this list in reverse and change it a little bit so that I delete the goal rectangles. So I'm going to do that now. So let's run our code and see if I can both collect goal rectangles and die from running into bad rectangles. Okay, let's see if I can collect this one. Something seems to have gone wrong. Oh, what went wrong was I didn't call the function. I never called check collisions. Well, that's really easy to fix. I go into my main file here. I go into my main loop, the while true here. And let's put it right after handling events, right after moving. Now it's not just check collisions. Again, it's functions.check collisions because I put check collisions inside that file. And the player is actually P here. Deadly Rex and Goal Rex are the same names that I used in this file. So let's run it again and see. So I made a mistake here. I'm just fixing this. This should be Goal Rex bracket I. Yay, I'm able to collect the green rectangles. And it should tell me that I'm victorious once I collect this last one. All right, it printed out victory. I have won the game. Great. Now let's also check to make sure that I can die. So if I run into any of these red rectangles, I should die. Bam, game over. Great, works perfectly. Now I would actually like to make this game slightly more interesting. I would like to have a vision radius for the player where they can only see a certain distance. All right, so I'm going to go into functions and I'm going to add a distance function. What I'm going to take as my arguments here are two pairs of XY coordinates. I'm going to take X1, Y1, and X2, Y2. And if you've not seen the distance function before, what it is the square root of the difference between x1 and x2, but that difference is going to get squared, use double asterisk for squared, plus the difference between y1 and y2, and that number is also going to get squared. All right, so that's my distance function. This is not going to work because I haven't imported math. Okay, so I better go up here and import math. Now, a real easy way to do it is just to say comma math, and this is fine. This is a perfectly good way to do it right here. But since we've been learning about this from constants, import whatever, let's try from math, import square root, because that seems to be all that we need, is just the square root function. Now I can go back down, and I don't need to say math dot square root, I just say square root. Okay, now here's how I'm going to use this function. The way I'm going to use this is instead of just drawing all of my rectangles on the screen, we're going to give our player a vision radius. Now, a good way to do this is to go into constants and make a new constant value. And vision radius sounds like a really good name for it. I don't know what the best value is, so I'm going to make something up. I'm going to start with 50 and see how this looks. And then instead of just drawing everything, what I'm going to do is I'm going to put an if statement in here and say that if the distance, and I'll have to fill in these actual variables, if the distance between the player and whatever rectangle they're currently looking at, or I mean whatever rectangle we're currently about to draw, is less than the vision radius, that's when we're going to draw it. So now only the rectangles that are close enough to see will appear on the screen. All right, so D is our rectangle. So I'll do D.X, I'll do D.Y, and then for the X1 and Y1 I need P.X and P.Y. All right, so my deadly rectangles should only appear in this radius. I'm going to test this before doing the same thing with goal rectangles, even though it's not very hard. Oh, so it says distance is not defined. So I forgot that distance is inside of functions. I need to say functions.distance. All right, really easy mistake to make, really easy mistake to fix. All right, so I can see these red rectangles over here. Let's see if more rectangles appear. Oh, yep, as I move to the right, I can sort of see these other rectangles as I get close to them. Whoop. So this is kind of a good game. It's a little hard to see very far, so let's make my vision radius larger. Although for a tough game, this would be maybe good settings to use. So let's double it, in fact, and make it quite a bit larger. Now it looks like it's working, so let's also put this code in for the goal rectangles. So I do a very similar thing, except instead of D, I'm using the letter G for my goal rectangles, so I need to change D to G. And this should work. All right, so now I can see more of the screen as I move through. Gotta avoid the red rectangles and try and find the green. Cool, I found one. All right, looks like our game is working pretty well. So just a little reminder, what are some of the things we looked at here? So the first thing we did is that we created a constants file. Constants, like that word right here, but lowercase c. We usually lowercase our file names. And anything that's going to stay the same, like we put in here, it's also really nice because I can change the size of the screen all in one place, the number of deadly rectangles, goal rectangles, the size of everything, default speed, all that good stuff. And then in main, I said from constants import star, import all the things from that file, and don't make us write constants dot right in front of them. Let us just write the name of whatever it is we want to print or use in any which way. After that, I decided that a functions file was going to be really useful. So I put handle events in it, put check collisions in it, and I put distance in it. I had to import some things to make this work, so I did that. That's no problem. I can import Pygame here and then also import Pygame in main. Nothing wrong with doing that. I imported functions just by name, separated by some commas right here. And then I used it calling handle events, check collisions, checking distance here. This is my whole main loop. This code right here is everything that is on my main while loop inside my main file. This is pretty short. It all fits on one screen. That is a really useful thing to be able to do, is to fit your main loop all on one screen. And it wouldn't be possible unless I organized some code into the functions file. Now lastly, I created a player object, right, in its own file named player lowercase. I gave it a bunch of functions for moving, for what its attributes are, how it collides, how it draws itself. And then in main, what I did was I imported it the same way I did functions, with a comma right there. And I used it when I created the player, and that's pretty much the only place I used it. This is just the word player right here. That's not actually the file. One of the things that I forgot to mention earlier was, why am I using self.x and self.y? Why am I creating rectangles instead of just keeping a rectangle variable around, right? This is the same line of code here and here. Typically, we shouldn't duplicate this sort of thing. The reason why is the rectangle, the Pygame rectangle, has the nasty feature that if I change its x value, it'll round it to a whole number. And then if I try and move by a decimal amount of speed, which actually I decided I wanted a decimal amount of speed, it's not going to behave the same way I want. In fact, it'll just round down. It would be a default speed of 2, not 2.5, and I don't like that. Like, I want to move by a decimal amount. So what happens is the rounding will still occur. It'll occur when I'm checking collisions. It'll occur when I'm drawing. But I will be able to move at 2.5 pixels per frame in this game if I just use my own x and y variable that are allowed to be decimal numbers. I think that's all I want to say. I will put up some points that you can earn by doing one of two things. So for a smaller number of points, you can add a time limit to this game. For a slightly larger number of points, you can add the feature where if the player holds down the space bar, which you'll detect in handle events, their vision radius gets smaller, but their speed goes up while they're holding it. So it's like a dangerous way to run through the level. And for an even larger number of points, I will ask you to create an enemy that will try to chase the player through all the obstacles in here, because I think those would be some fun additions to make this more of a real game, although it's not bad as is. It just doesn't have many features.